Okay, now we're going to talk about again chemical bonds and formulas, and now we're going to take a look at how to write the names and formulas. All right, and we're specifically still going to talk about ionic compounds, but more importantly, simple ionic compounds. Okay, here we have an example, sodium and chlorine. What if we put the two elements together? Well, when you put the two elements together, in the previous lessons we've learned how to write the ionic diagram or the valence electrons diagram or representation of it like this. And so what you have is the sodium ion and the chloride ion right here, all right, or chloride. Also, you may see this representation kind of like this, a little spheres or balls with the sodium ion and the chloride. And now, the thing is, how are we going to figure out the name for these elements? Well, I know you have heard this billions times, and you're probably so used to knowing the name of the compound with this element and this element, but I'm going to just give you the rules so that you can name a whole slew of other compounds, but I'm just using this as an example. Alright, rules to naming simple ionic compounds. 1. The name for the cation is the same as the name for the element. Alright, so in an ionic compound you will have the cation and the anion. And so the name of the cation here will be the same, will take on the name as the same as the name of the element. So if this is sodium, the ionic name for this portion of the compound is called sodium as well. Rule number 2. The name of the anion takes the root name of the element followed by the suffix IDE. Followed by the suffix IDE. Alright, so for example, this chlorine here is now an ion, an anion. So the anion part of the name will take the root name of chlorine, which is chlor, and followed by the suffix IDE. So it's chloride. So what you end up with is the name sodium chloride. Alright, so that is the name of this compound. Alright, next we're going to learn how to write the formulas for these simple ionic compounds. Well, it's pretty easy. First, there are two ways to do it. The theoretical way of understanding the balances of charges, and the second method, which is a shortcut method, which is assuming that you've already understand the first theoretical method, is the drop and swap technique. So first, the theoretical technique. When you want to write the formulas for ionic compounds, you have to realize that ionic compounds, when it's in its solid state, they are electrically neutral, which means that there must be a same ratio of positive ions and negative ions, which means the formula has to have an equal number of positive charges from the cations and negative charges from the anions. Okay? So here, sodium has a positive charge, so it only has a charge of 1. Chloride has a negative charge of 1. So 1 sodium will always be neutralized or balanced out. The charge of the sodium will always be balanced by the charges from 1 chloride. So you have a 1 cation to 1 anion ratio, a 1-to-1 ratio. So in that sense, you will have 1 sodium and 1 chloride, and that's the formula. Okay? Now, you really don't need to apply the shortcut techniques for these methods because this is relatively simple. But now let's talk about slightly different groups of elements. So this was group 1 and this was group 7. And now let's talk about magnesium and sulfur. Okay? Just going to change these things in here. Just going to change these things in here. All right. It's going to take me a little bit. Be patient. Okay. Now I have magnesium and sulfur. Now I have the ion of magnesium and an ion of sulfur. Okay? And what we notice is that magnesium has 2 valence electrons, and when it becomes an ion, it's going to donate 2 of its valence electrons. And sulfur has 6 valence electrons, so it's willing to accept 2 valence electrons from magnesium. And so it becomes negatively charged, which is an anion, and magnesium becomes a positive charged ion, cation. Magnesium is 2 plus, and sulfur ion is a 2 minus. But now, when you put the two together, what is the name of the ionic compound? Well, remember the rules. Name of the cation takes the name of the element. So the name of this compound, for the portion of the cation, should remain as magnesium because of the rules. And sulfur is no longer called sulfur, but the root of the word sulfur is sulf. Okay? And you end it with the suffix IDE, so you still get that. And so your name of this compound now is called magnesium sulfide. Okay? Magnesium sulfide. Now, how would you write the formula for magnesium sulfide? Well, here you have a 2 plus charge, here you have a 2 minus charge. The charges balances out. So you only need 1 magnesium ion with 1 sulfide. Okay? And so your formula will be Mg, 1 Mg, and 1 sulfide. Yes, MgS, that's magnesium sulfide. Brilliant. What about something slightly more complicated? Okay? Okay. What if we had potassium and, let's say, nitrogen? Okay? Potassium in its ionic form will be K plus, and nitrogen in its anion form, it will receive 3 other electrons from somewhere else and becomes a negative, 3 negative charged ion. All right. So what will the name of this thing combined be? Okay. First, the name of the cation will still be potassium because that's just the element that we are working with. And now nitrogen ion takes in the root of the name nitro, and you add it with an IDE. So the name of this thing is called potassium nitride. Now notice that the charges for potassium and the charges for nitride, the charge for potassium and the charge for nitride are not equal. All right, they are not equal. And this leads out to how we're going to write the formula. How we're going to write the formula. And you notice that you have 1 plus here and you have 3 minus here. So you need 3 potassium ions to neutralize 1 nitride, okay, to balance out the charges. So in actual fact, upon collision, to form a compound, you need 3 potassiums to be ionically bonded to 1 nitride. That is it, okay, so that the charges, that's cancelled out. Now, how do we write the formula for that? Well, first you know that there are 3 potassiums ions to neutralize 1 nitride. Okay? So when you write the formula will be written like K to represent potassium. And how many Ks do you have? You have 3. So instead of writing it in front of the K, like you normally would for algebra or whatever have you, chemists write the 3 at the bottom right corner of the symbol, the potassium symbol. This is to indicate that you have 3 potassium. Because if you write it in front of the symbol, you would think that you're talking about 3 elements of potassium. But if you put K3 like this, that means this K is most likely going to be an ion, which will represent that it's an ionic compound. And so, how many nitrogens do you have? You have 1. So theoretically, you should write a 1 down here. But because you don't write 1x, you don't write x as 1x, you write just x as x to represent 1x. You do the same thing here for nitride. Alright, so that's the formula. Now, you can use this theoretical technique to write the formulas. However, I'm going to talk about using the drop and swap technique. So, drop and swap technique. The drop and swap technique involves you knowing the charge of the ions. So here I have plus, K plus, and I have N3 minus. And what I'm going to do is take the coefficients or the numbers in front of the charges. So here, because there's no numbers, it means there's 1 in there. And here the coefficient for this nitride is 3. And what I'm going to do is I'm going to drop and swap these coefficients to the bottom right corner of the symbols. I'm going to drop and swap it to the bottom right corner of the symbols. And so what I end up having is K, okay, 3 from that nitride here, N. And what's the charge of, how many N's do we have? We have 1, but because it's 1, we don't write it down, and so it is represented like that. Okay? Wonderful. So there you go. Techniques to write names and formulas.